Hello students, today we will see the first chapter, that is Introduction to Data Structure and Algorithm Analysis. This topic is introduced in SYBSc Computer Science for semester 1. I, Sheetal Jagtap, Assistant Professor in Kekewa Graduate College. There are some important terminology used in this chapter. Now we will see one by one. From that, first one is data. Data is a collection of numbers, alphabets and symbols combined to represent information, which consists of two parts. That is atomic data and second one is composite data. Composite data. Whereas atomic data are non-decomposable entity. For example, integer 543. This number is not further divided like character A. This also not further divided. Okay. Whereas composite data can be divided into further atomic data like date. This date can be divided in three parts. That is day, month and year. This day, month and year, these are not further divided. Hence, these are called as atomic data. Then the definition of composite data are nothing but what? Further divided into atomic data are nothing but composite data. Okay. Second terminology used in data structure is ADT. That means abstract data type. ADT. The concept of abstraction is commonly found in computer science. A big program is never written as a piece of program. Instead, it is broken down in smaller modules and each module is developed independently. The next is data object. Data object. Data object refers a set of variables used in a program. It is a place where the data values can be stored, retrieved and manipulated. Every data object is associated with data type. The third one is data structure. Data structure definition is totally depends on triplet. That is, data structure is formally defined to the triplet like DFA, in which D stands for a set of domain, whereas F denotes the set of operation or a function and A denotes a set of axioms. Okay, there are three types of data structure we will see in this topic. First one is primitive data type and non-primitive data type. Primitive data type and non-primitive data type, in which primitive means integer, real, logical, character, pointer. These all are included in primitive data type or data structure. Whereas non-primitive data structure means array, structure, linked list, graph, tree, queue, stack. These all are included in non-primitive data structure. Second data structure included linear and non-linear data structure. First of all, we will see linear data structure. Linear data structure, in which that can be represented in two ways. One is array and another one is linked list. First of all, we will see how we represent linear data structure in array. As we know, an array consists of some element that will start from 0th position up to n-1 position. And there are some elements included in a list. These are the 0th position and this one is n-1 position. Okay. Now, array can be considered in stack as well as in queue. If we represent elements inserted in stack, whenever the elements are inserted, suppose 1, 2, 3, the last element considered as a top in stack. Whereas in queue, there are two parts, that is front and rear. Suppose these elements are inserted, then this one is front and this one is rear. These all are included in array. Now, same concept we will see in linked list. But there are nodes. This is called as a node in which this contains value and next part will contains the address of another variable. Okay. For example, 1 is the element and this will contain the address of another element. And if list is ended, then we will consider this symbol. This also can be represented in two ways, that is stack and queue. Same concept, that is the list is ended with null and this is the top. The last element considered as a top in stack. And same for a rear, 1 and 2. This is the front and this is the rear. This is the concept included in linear data structure. We can represent in array as well as in linked list. The second subpart of data structure is non-linear data structure, like graph, tree, table, that all are included in non-linear data structure. Non-linear data structure like tree, graph, and table. These all are included in non-linear data structure. Now, the last type of data structure is static and dynamic. Static data structure and dynamic data structure. Static and dynamic. Static. In case of static data structure, memory of object is allocated at the time of loading of program. For example, integer a of 50. That means 50 elements can be inserted in variable a of data type integer. But there are some drawbacks, like if I want to insert 60 elements, then there will be an error because I have already declared the size 50. If I use 40 elements in this variable a, then there is a 10 elements are remaining, that is wastage of memory. So to overcome this, we use dynamic data structure. Whereas dynamic data structure are nothing but the memory required by the variable in which it is calculated by using malloc function. For example, x is equal to int star malloc 100 into size of int and close the bracket. This is the syntax or example of dynamic data structure. So there are many more interesting topics in this chapter that we will see in the next lecture. If any doubt regarding to this today's topic, then you can comment me in comment box. Thank you.